Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And we want to teach ourselves how to get the constant of an integration, because we've been told that if you integrate the derivative of a function with respect to x, it's going to give you the function plus a constant. Now we want to teach ourselves or to learn how to acquire that constant. And the reason why we must acquire a constant is because supposing we have a function uh, that has y is equals to x squared plus 2. At the same time, we may be having y is equals to x squared. At the same time, we will be having y is equals to x squared minus 2. If we would wish to sketch this graph, we know it's going to be passing at point 2, and it's going to be that way. If you wish to sketch this graph, it's going to pass through the origin because the y-intercept is 0. Here the y-intercept is 2. It's going to pass through that particular point. If you wish to sketch this graph, you're going to realize that it's passing through -2 because the y-intercept is -2. Regardless, it's going to be just that way. So if you want to deal with a specific function, you must then know the value of c so that during construction you can be talking about a particular curve. How then do we do this? There are 3 steps. First of all, integrate. You should integrate the function. First of all, to find c, integrate the function. After you integrate the function, then you substitute any information given, substitute any information given, e.g. you could be having x, y, one coordinates where the curve passes, or you could be given or fx can be given to be equals to a certain value. Then you would exactly know how and where to integrate. I will teach this. You substitute any information given, e.g. x, y, or fx is equals to k, into the integrated function. And of course, step 3, you solve the equation. Solve the equation to find c for that matter. And to teach us this, I want us to directly go to example 6. And in example 6, we are told that the curve C with equation y is equals to fx, the curve C with equation y is equals to fx passes through the point 45. It passes through the point 45. Given that f prime x, or rather the derivative of the function, is x squared minus 2 and everything over root x. Now find c. That is the question. Before we can go further, first of all, if we are looking for the constant, we must have had the function itself. The equation of the curve is what we are looking for, and because we are looking for a specific curve, not curves that are general like what we have here. We're looking for a specific curve. That means we need to get the function, and very accurately. The first step is integrate the function, and of course the function, or rather the derivative, is, let's make x as free as possible, is going to be x squared over x raised to power a half minus 2 over x power half, which is x 3 over 2 because of 2 minus a half minus 2x minus a half. That is now the function which we need to integrate. And integrating this means we integrate x 3 over 2 minus 2x minus a half with respect to x, which gives us x. This power increases by 1, 5 over 2 over 5 over 2 minus 2x a half over a half plus c. Now, having had this, let us clean it up a little bit and see what we need to have. We're going to have 2 over 5 because of multiplication by the reciprocal, x 5 over 2 minus 4 because of again multiplying by the reciprocal, x half plus c. Now we are told that the curve passes through 0.45, and of course we need to understand something. This is now the y. This is now the y because we have integrated the differential to get the function. And if this is the y, it could also be remembered by all of us that it is also now the function of x, which is y, which is this. Passing through, we are now in step 2, passing through 4, 5. We are in the second step. The first step is integrate the function. The second step is substitute any information given. We are now at that particular point whereby this is the information given to us, that when x is 4, y is 5. Then we need to substitute this in the function 5, because y is 5, is equals to 2 over 5, and then 4, 5 over 2 minus 4, 4 a half plus c. And it goes without saying that at this particular point we need to just operate this, because as you can see we have 2 over 4 raised to power 5 over 2. What is that to start with? 4 raised to power 5 over 2 by itself is the root of 4, which is 2. 2 raised to power 5. 2 raised to power 5 is 32. So we are going to have 5, this one, is equals to 2 over 5 times 32 minus 4. This is times 2, because 4 raised to power half is equals to 2, of course, plus a c. And at that point, we can say that we can go further to simplify this and have 5 is equals to 64 out of 5 minus 8 plus c. Fine, and our c is now very easy to be obtained. We are just almost very near to obtaining our c. So from this, if you make c the subject of the formula, it's going to be c is equals to 5 plus 8 minus 64 out of 5. 5 plus 8, let's see, 5 plus 8 minus 64 over 5. And what is that? It's a fifth. It is a fifth. Is 1 over 5. That is our c. So if our c is 1 over 5, then the function of the curve, the equation of the curve becomes y is equals to this one we now see substituted 2 over 5 x raised to power 5 over 2 minus 4x raised to power a half plus 1 over 5. Now it becomes a very specific function passing particular points. Otherwise, if C is general, you may never know what is the y-intercept, and everything else can just be accommodated and comfortably accepted. But for now, we have been able to find our C, and that is just like it. So please again, that is the end of chapter 9 of Pure Mathematics 1, and entirely the end of the unit. So let's get to my YouTube channel, PS1 and Excel International Maths by Mr. Kamotho. Subscribe and share widely, and let us work together. All right.